Hi everyone, my name's Nigel Bayliss. I'm the Optimizer Product Manager. Before I continue, I just want to draw your attention to the Safe Harbor statement so that I suppose it kind of says that anything I say, don't believe, but it's basically a legal requirement and draw your attention to it. So I'm the Optimizer Product Manager. I maintain the Optimizer blog that you might have seen at blogs.oracle.com. I tend to keep that pretty much up to date with the things that tend to come up via customers and what have you. So it's really for me to hopefully make you aware of some of the kind of latest issues or the latest new features. So I think it's a good place to go. So it's pretty active. I tend to post every couple of weeks, something like that, or a month or so. And also I have a Twitter account on VLDBB, which actually stands for Very Large Database Bayliss, which is kind of alludes to my background, a long time in the industry, working on large databases in particular, all on Oracle, of course. So the purpose of this session really is to take you from Oracle Database 12c Release 1 through to Oracle 18c. Now, I guess a lot of you are going to be very familiar with 12c Release 1 and maybe 12c Release 2. So why am I covering some of that? Well, the reason I'm doing that is because I want to take this chance to incorporate some of the lessons learned from customers that have upgraded to Oracle Database 12c. So in other words, there are certain things that we changed, certain changes to things like default behavior that to some DBAs was kind of confusing, basically, you know, what's happened. And so I really want to make you aware of those things. And also a fair bit changed between 12c Release 1 and Release 2 regarding the optimizer. So also I want to make that very clear to you what happened there, and plus some of the backports that we made to Release 1 as well. So if you're currently running on Release 1, I'm hoping that some of this session is going to be of use to you as well, because if you are, using Release 1, you're familiar with Release 1, there are some things that I want to make you aware of that happened in Release 2 that you should know about. So the focus is really not so much on there's this feature, this feature, this feature. What it's more to do with really is focusing on what you as Oracle database experts need to know, the kind of things that I think are important that you do know, and the things that may affect the way you manage the database or may affect the way you interpret things that are happening on the database. So it's that kind of things really. And also we've changed things like some of the best practice over time and some recommendations I think that you may not be familiar with. So I want to cover those as well. So yeah, generally the plan is to make you more effective at kind of managing the environment and understanding the things that are changing as we go from 12c Release 1 to 18c. So just to set your expectations a little bit, if you like, this represents the kind of step changes between the releases I'm going to talk about. So as you might expect, the major release 11G to 12C Release 1 was quite a big jump. So there's quite a lot of material there. And then from 12C Release 1 to Release 2, again, as you'd expect, there are fewer changes. And then, in fact, regarding Oracle Database 18c, it's really, I think, best to kind of think of it in terms of 12.202. So it was quite a minor release. So if you like, the jump in features between 12c Release 2 and Database 18c for the optimizer was a relatively small step. So there are definitely fewer features in that jump. And in fact, the features that we did incorporate between really 12c and 18c were focused, I would say, very largely on the Autonomous Data Warehouse Cloud, which you may have come across. There's a link there if you want to go and check that out. So yeah, so a lot of the optimizer features were directed very specifically at ADWC. And these are the topics for today. So as I mentioned, there's a big step between 11G and 12C, but I'm actually going to concentrate on the things that are, I think, particularly important to be aware of if you're a database administrator, database designer, that kind of thing. And then, of course, I'm going to continue on into database 12c release 2 and 18c. So there's the agenda, a little bit on release 1, release 2, some of the new recommendations and best practice I'm going to cover as well, and then something about ADWC and the features that are incorporated in that. Okay, so database 12c release 1. So I'm sure you're all aware of histograms. So these are additional column statistics that account for skew, and they account for things like value skew, where you have particular values in columns that have very disparate cardinalities. And also, I guess less well known, it accounts for range skew, which is where you have kind of holes in ranges of data. Again, that is a type of skew that we need to take into account. So that's another thing histograms are directed at. So prior to Oracle Database 12c, you had frequency histograms and height balanced histograms. The height balanced were targeted at high NDV, which is where the column has a high number of distinct values, and the frequency histograms were targeted at a low number of distinct values. So that was prior to 12c. Now in 12c, there's new histogram types. I'm not going to dive into the detail of exactly the set technicalities there. The differences are there. I think the key thing to be aware of, really two things, is that there's a new histogram type, and I'll explain the significance of that in a minute. The other thing is that the new histograms will only be created if you're gathering statistics using the estimate % at auto sample size. That is best practice, has been for a long time. I think sometimes DBA sometimes set this value, but if you do that, you won't get the new type of histogram. So just bear that in mind. If you're upgrading, for example, you need to consider moving to auto sample size, which is the current best practice. The next thing, so just to mention that top frequency histograms, this is kind of what they look like. The idea behind them is that if you have a very large number of values for certain column values in your data, but there's lots of different values, but they're kind of insignificant. Oracle can basically pick the most significant values from the values in the table and create a histogram on those. So it's kind of like basically it's rather like a frequency histogram on the most common values in the data. So that's what the top frequency looks like. Height balanced tend to look like this, where you have a high NDV and they cover a range of column values, and they're called height balanced because generally speaking each histogram bucket is a similar size. So the new histogram type there are hybrids. So they kind of refine the way the height balance works. So they're very similar to height balance, but they refine the way that the values are statistically held, if you like, which gives you better cardinality estimates. So the idea behind hybrids is if you have height balanced previously, when you move to hybrids, your cardinality estimates will be better. So this is what it kind of looks like in the database. So if you look at the column tab, the tab column statistics, you'll see the histogram types change. So that's the first thing to bear in mind, that when you upgrade from say 11G to 12C and you gather statistics, you're going to get these new histograms. So they get recreated as say hybrids from height balanced, or they may become top frequency as well. So that's the physical difference. Now, of course, as I mentioned, they give you improved cardinality estimates, which does mean that you do get different cardinality estimates on an upgrade. So when you gather statistics going into 12C, the height balanced histograms will be converted or replaced by hybrids and top end frequency histograms. And as I mentioned, it's only if estimate % is auto sample size. So again, if you're upgrading, just be aware that that's happening. It can change SQL execution plans because the cardinality estimates change. So incorporate that into your testing. Bear in mind that when you're testing an upgrade from 11G, for example, to 12C, be aware that the histograms are changing. if you have them in your database, and be aware that that can have an effect on SQL execution plans. The other thing that I guess that not everybody was aware of is the change in session private statistics for global temporary tables. So what this meant is, prior to 12c, if you gathered statistics on a global temporary table, those statistics were shared by all sessions. That's not always a great idea, because each session may have a different set of data in the global temporary table. So more often than not, you probably want statistics that are relevant to the session that owns that data. So in fact, that's what happened in 12c. We changed the default so that statistics were session based. So in other words, if you gather statistics on a global temporary table, it would only be seen by the session. Now, that can cause issues if you're coming prior to 12c, because you may have, for example, a batch flow that depends on you gathering statistics at the beginning that are shared, and then those statistics are shared between a number of sessions further down the batch flow. Now, if you do have jobs like that, for example, then you probably want to consider whether you should change the default. So, for example, you can set table prefs to change it back to the shared model. So bear in mind that if you are seeing plan changes on global temporary tables, check to see whether you should be doing this. So in other words, do you need to keep the pre-12c behavior for statistics on global temporary tables or not? So I mention it here because it's definitely something that caught out some DBAs. They didn't see that this was a big difference. So they weren't aware that those statistics that were gathered at the beginning of the batch, for example, weren't being seen downstream by other batch jobs. So it's important to be aware that that difference has happened. Another thing that changed was we automated the evolution task. So if you use SQL Plan Management, you'll be aware that there's an evolution task. So the evolution task basically looks for new SQL execution plans, validates them, and will accept them. Now, a lot of you out there have been using things like SQL Plan baselines in a very kind of targeted manner. So in other words, you created a SQL Plan baseline, you assume that it would not evolve. In other words, you kind of let it sit there and you left it. So what some DBAs would see is, if they used it in that fashion prior to 12c, is when they upgraded to 12c, all of a sudden they were kind of getting these evolved SQL Plan baselines, which, you know, initially was confusing. Where are they coming from? So be aware that this task exists. You can disable it, but my recommendation is here on the right-hand side that you set the evolve task parameter to accept plans false. So if you don't want evolution to happen, then you can set the evolution task so that it's the evolution advisor, so that it doesn't accept plans by default, which means that if you have new SQL execution plans over time, the evolve process will run on them, validate those plans, figure out whether they're good plans or not, but it won't auto accept them. So in that way, you can gain benefit from SQL Plan Management and see new plans, but they don't get accepted. That's under your full control. So if you're used to using SPM in that manner, where you're controlling individual SQL statements, you're controlling how evolution works, then bear in mind that the auto task will do something different if you go from, say, 11G to 12C. Okay. So now this is the big topic, the adaptive optimizer. Now, again, I'm going to cover this very much from a database administrator's perspective, less about kind of how it works really, but more about the way that metadata is handled, what effect it has on SQL execution plans, and how you manage that. And then more importantly, I'm going to cover what happened between 12C release 1 and release 2, and then also cover what recommendations I have for you on that. So we've got some very specific recommendations, and also then moving on to 18C as well. So the idea of the adaptive optimizer was to identify cardinality misestimates. So in other words, when a query executes, sometimes there are issues with, the complexity of where clauses, maybe even statistics that show up issues with cardinality. So when the query executes, we may see big disparities between the number of rows that were estimated versus the number of rows that we actually saw. Under those circumstances, we would like the optimizer to figure out what's happening and obtain better cardinality estimates, so that, in other words, next time we get a better SQL execution plan. Because better estimates, of course, improve SQL execution plans, because if we get our cardinality estimates closer to reality, then we're more likely to get the best or better SQL execution plans. So in order to do that, we want to share metadata as well. So in other words, the idea is that if we issue one query and we learn about cardinality estimates that we might see, we want to share that information between different queries. And what's nice about that is that if we execute query A, and in particular if you have an ad hoc type environment, so a business information system where the queries are different each time, we want to learn from the first one, say, and then down the line we may be able to apply what we learned to different queries. So that's really the kind of basic idea behind it, that we kind of persist this metadata and learn over time. And on the back of that, we'd like to improve the statistics we have. So in other words, if cardinality estimates aren't correct, then maybe we should create new histograms. Maybe we should create extended statistics in the form of column group stats. Maybe we should create those to improve our cardinality estimates downstream. So these are actually really powerful ideas, but they do have some side effects which cause some issues for some systems out there when customers upgraded to 12C release 1. So I'm going to cover something on that topic. And then I'm going to go into what we did to improve the situation, and then cover the recommended approach, what you should do. So with 12C release 1, we had this umbrella feature called Optimizer Adaptive Features. And below that, it's actually split into two branches. So this is called adaptive plans. So the idea behind adaptive plans is it's something that happens at runtime. So in other words, if we have a query that is estimated, if you like, the best plan is estimated to be a hash join. When the query starts to execute, we monitor that query. And if it is established that, in fact, a nested loop join would be better, we can actually switch the plan, adapt it at runtime from the hash plan to the nested loop plan. And that that happens once. So in other words, on initial execution, we figure out whether the hash or the nested loop was better, and then we choose the best one of the two. So we have like a concept of the base plan, if you like, which is the one that we think we need. Excuse me one moment. We have the base plan, the one we think we should choose, but at initial execution we may flip from one to the other. So that's adaptive plans. In fact, from a database administrator effect, that's very low overhead, very easy to understand. It kind of happens on execution, and it's kind of done. So it's a very easy thing to deal with, in fact. And it's proved to be a very successful feature too. It's something that works very well, and we definitely highly recommend that you use that. And I'll go into that a little bit more in detail soon. The other feature is adaptive statistics. So this is the idea where we learn from previous executions and we choose better SQL execution plans. So this is something that is more difficult, if you like, from a database administrator's effect because of the concept of adaptation over time. So again, I'm going to talk to you about that in a moment. So that's adaptive statistics. So adaptive stats is very much kind of a learning process where we store metadata, and the SQL execution plans change over time. Okay, so this is what you had in Oracle Database 11G. It's worth taking a quick look at that. So you had a feature called cardinality feedback. So the idea here was kind of, it's almost really like the kernel of adaptation, in fact, although it wasn't called that in Database 11G. But the idea here is that when you execute a query, we learn over time whether the cardinality estimates are not right. And if they're not, we can actually adjust the plan of that query. And it's this information, this kind of feedback loop, because if you like, if it's worth thinking of this as kind of a feedback mechanism, this is on a query by query basis. So it's not something that's going to be shared between queries. And once the query is aged out of the cursor cache, that information's lost. So it's something that happens as a query initially executes. And it's sometimes the reasons why you'd see a plan change. The query would execute. We'd see that the cardinalities were wrong, and then the next time it's executed, we'd then reparse and then see if we can find a better plan. So there's that kind of little feedback loop that occurs. So you've had that in 11G, of course. And the other thing that occurs is that we store information about the columns that are being used in where clause predicates. That information is tracked, held as metadata in the data dictionary. So remember, this is all 11G, or what you're used to, of course, if you're using 11G. And then beyond that, if you gather statistics using the default mechanism, which is for all columns size auto, you can be given histograms. So we can create histograms automatically when statistics are gathered. So if you like, this is kind of the concept of improving statistics over time based on issues that we see with cardinality. So this is a fully automated process, and something, again, as if you're using 11G, that you already and currently have. So now when we look at 12C, you'll see a similar kind of process going on. So let's have a look. Okay, so in Oracle Database 12C, the first things that changed was a name change. So we changed the name of cardinality feedback to statistics feedback. And in fact, there was another change that occurred along with that, in that we also fed back cardinality with respect to joins. So queries that included joins, we would also include feedback about join cardinalities. This actually had a side effect in that it made the statistics feedback or cardinality feedback somewhat more dynamic. So what that meant was there were more queries that saw these statistical mismatches, cardinality issues. So what you tended to see was a more frequent plan changes. And I guess that's something that took some people by surprise and affected some systems. So for that reason, it's something we looked at and addressed in release 2. So I'm going to come to that shortly as well. Then, of course, with 12C, we added adaptive plans, this sort of runtime adaptation, which has always proved extremely successful, easy to look after. It's a very nice feature. We definitely recommend its use on all systems. So it's one of those features that's pretty much applicable to every system. Okay, next we have the concept of SQL plan directives. So what that means is that in this loop here, this feedback loop, if we do see cardinality misestimates, then what can then occur is we can create these objects or structured called SQL plan directives. I'll show you how to see those shortly, but the idea is, in fact, that over time as queries execute, we will collect this metadata. This metadata persisted to the data dictionary, shared between queries. And what the effect that it has is, if you issue a query and the optimizer sees a SQL plan directive that is relevant to that query, and that means it has where clause predicates that are associated with the SQL plan directive, we can then issue dynamic statistics queries. So these are sampling queries that are executed by the optimizer to sample the data physically in order to get better cardinality estimates. So I like to think of this again as a feedback loop. So you have the optimizer, which feeds into SQL plan directives, which causes, so what happens at parse time is that a query comes in, we look at SQL plan directives. If it has SQL plan directives that are relevant to the query, the optimizer can then issue dynamic statistics queries and figure out how it should improve the cardinality estimates it's got. Okay, so in other words, the lessons learned from previous executions are shared between queries. Now, one of the side effects of this, there's a couple of side effects which I'll talk about, are that it increases the parse time for some queries. So if you have a high parse rate, a high hard parse rate, it's a hard parse, then what you can see are these dynamic statistics queries becoming quite dominant in the workload. So that's one of the things that was an issue for some systems on Oracle 12c database release 1. I say it's some systems, but it's something to be aware of. And again, I'm going to cover what's changed and what we've done about that as well. Okay. The other thing of note is that not only do we create histograms if you gather statistics for all column size auto, when you gather statistics, we will also create column group statistics based on SQL plan directives. What that means is that, for example, if we see that there are correlations in values between columns, for example, we will create column group statistics. The idea behind that is that when queries now come in, they will take these kind of correlations into account. So the idea there is, in fact, that we get better estimates first time. So in other words, we're improving statistics over time based on the queries that are coming in, just as we did with histograms, in fact. So it's a similar kind of mechanism. Just so that you're aware, as a database administrator, for example, this is where the metadata can be seen. So if you're using 12c, you can see that metadata. And be aware that it changes over time, because over time that metadata will evolve. So you can see them saying DBA SQL plan directives. You will see the SQL plan directives being gathered there. Okay. So adaptive statistics, note the asterisk. This only means adaptive statistics, not adaptive plans. Okay. In fact, I've got a typo here. So this is actually should be not adaptive plans. Let me just quickly make sure that's incorporated into the deck. I don't want you to get the wrong end of the stick. Editing on the fly there, sorry about that. Okay, so adaptive statistics, the optimizer adapts over time. So in other words, as a database administrator, you need to be aware that that metadata exists. You may, for example, have a pre-production system that populates that metadata. Remember, this happens automatically. So maybe you want to copy that data from the pre-production system to your production system. So you need to be aware that it exists. And you could do that with data pump. It's an easy process to do, but you need to know that you might want to do it. That's if you're using adaptive statistics, okay? So adaptive statistics do have an overhead in systems with very high parse rates. Obviously, hard parse rates are not best practice, but there are definitely systems out there, of course, that do that. You know, OLTP style systems where there are a lot of parse, like literals and things like that, where the parse rates are very high. You'll get more dynamic sampling queries. And some customers saw things like library cache contention because of extended parse time. So if they had hard parse rates, you could see extended parse times, and that would result in a library cache contention thing. You would see that. And occasionally you would see RC latch contention as well in 12c release 1, which has now been fixed in release 2. So you shouldn't see that anymore, in fact. So let's see what happened in 12c release 2. So the first thing we did, we obsoleted optimizer adaptive features. So this was the parameter that controlled all this adaption. So what we did then is we basically acknowledged the two branches, optimizer adaptive plans, optimizer adaptive statistics. So these new parameters came in with 12c release 2. And we also changed the defaults. So one of the motivations for these new parameters was to make the control finer, because the optimizer adaptive features parameter was too coarse. It was a big switch to turn on and off. So instead, we've given you finer control. And the other thing that we've given you is the adaptive plans are on by default. We see those applicable to all types of systems. Whereas optimizer adaptive statistics is off by default. So we have established that this is a better default for the majority of systems. So I'll talk a little bit more about that in a minute. But so this is now off by default. So what does that look like? So in 12C release 2, you do have the ability to go fully adaptive. So it's just like release 1. So if you're using release 1, you're happy with full adaptation. It all works the same way in 12C release 2 if you switch everything on. So it's possible to use release 1 and release 2 in exactly the same way. But these are the new defaults. So this is what the new defaults look like. Of note is that, first of all, statistics feedback is now rather like cardinality feedback. So we don't include join feedback. The effect of this loop now is that plans are not so dynamic. So they don't change quite as aggressively as they did in 12C release 1. The next thing that's happened is that, well, we still persist SQL plan directives, but this feedback loop now is just broken. So in other words, SQL plan directives no longer direct dynamic statistics by default. So if you are getting dynamic statistics queries, they're the ones that you've asked for, or if there are statistics missing, essentially just the way that it worked in 11G. So in other words, when your hard parse is high, you're not going to be generating this kind of, you're not going to be going around this loop generating the higher hard parse rate, hard parse overhead. So in other words, what we're essentially doing is making this behavior more like it was in Oracle Database 11G. And then the other step is that the SQL plan directives don't affect column group statistics by default. So we don't have this step. So when you gather statistics, you're not going to be generating new column group statistics, okay, from the existence of SQL plan directives. The interesting thing, I guess, to note is that you do get SQL plan directives generated. So if you look at DBA SQL plan directives, you will still see them being gathered, even though you may turn off adaptive statistics, which is the default. So this is really a kind of reiterating what the default is. So that means optimize adaptive plans is true, optimize adaptive statistics is false, and there's also a DBMS stats preference called auto stat extensions that is default off. So that's how this step is controlled. Of course, you can turn it on if you wish, but by default, it's turned off. And we believe, again, the default is the best setting. So I guess the lesson really, the takeaway from 12C release 2 is to use the defaults. So Oracle Database 12C release 2, the defaults cover the widest range of workloads. They offer finer control, so it's easier for you to prioritize query stability without turning all features off. So it's a fine control mechanism. If you need to prioritize query plan stability over everything else, the default settings are the best. So in the context of upgrades, the defaults are much close to the behavior of Oracle Database 11G. Okay, so let's look at if you're currently using Oracle Database 12C Release 1, what do I recommend? So this is what certain customers have done in the past. They've been doing things like setting optimizer adaptive features to false. This is quite a big hammer to crack a nut. I'll show you what that looks like in a moment. Excuse me one moment. Okay. Yeah, so it's a big hammer to crack a nut. It turns all adaptive features off, but I think I consider it too big a hammer to hit 12C with, but it's something that a lot of customers have done for now in order to get over any issues they may have experienced with the adaptive defaults. Some customers have optimized their adaptive features back to 11.204, which is seen as a quick fix. So these things are possible. So if you have, for example, plan instability on certain systems or a high parse overhead, these are things you can do on 12C release 1, but there are now better options available to you, which I'm going to cover shortly. So this is what it looks like if you turn everything off in 12C. The problem here is that you lose the sort of statistics or cardinality feedback step here, which is not ideal really, but you know, it definitely is a system that's kind of loses all the adaptive features, of course, if you turn them off. So it's not an ideal solution, I would say. The solution that we recommend if you're using Oracle 12C Release 1 is to apply the latest proactive bundle patch. So that's greater than equal to October 2017. And so it's incorporated in October, April, what have you. If you apply this proactive bundle patch, nothing new happens initially. So you have to proactively enable the new features, and that's done with a set of fixed controls. So what I recommend is you go and look at this doc, which will explain how to do this. What does it do? In short, if you enable the features in the proactive bundle patch, then if you enable the features that are available in the bundle patch, then you will have the parameters that are available in 12C Release 2. So the parameters in 12C Release 2 will become available in database 12C Release 1. So essentially what that means is your 12C Release 1 will behave like 12C Release 2 in terms of the adaptive features. Okay, so this is what it looks like with 12C Release 1, bundle patch, and active fixed controls. So if you choose to use this option, then it means that the adaptive features work in a way very similar to 12C Release 2. So the advantage of that is it conforms to best practice. It gives you more stable SQL execution plans. And for systems that have high parse rates, you're not going to see this overhead associated with parsing. So recommendations now for 12C Release 2. So if you're on 12C Release 2, use the defaults. Again, so if you want to physically set the parameters and extensions, then you can do that yourself. But otherwise, if you leave everything alone, you'll be using the defaults as is. And the same applies to Oracle Database 18C. So again, use the same defaults. So this is what the recommended defaults look like. You'll have statistics feedback for single table cardinality, so it doesn't include the join feedback component. You will gather SQL plan directives. They won't be used to adjust statistics, and then you don't get this feedback loop either associated with higher parse times. What about using adaptive stats? So adaptive statistics, I work better for things like ad hoc workloads where you have longer running queries, you have lower hard parse rates. So it's nice for things like BI scenarios, DSS workloads where you have big complex queries that are difficult to optimize, because obviously in those environments, those type of queries are more complex and require more optimization anyway. So in other words, the adaptive statistics, the overhead associated with that, it's worth taking the hit on that in order to benefit from the better SQL execution plans down the line. You can start with the defaults and you can test the benefit. Obviously, that's something that would be worth doing, for example. But bear in mind that if you're running, say, your test multiple times, that it will take some iterations before the best performance is reached, because remember that the metadata is being gathered over time. So the optimizer essentially evolving its statistics over time. So Bear that in mind. Also remember that you'll need to gather statistics if you want to take benefit from additional histograms and column group statistics, okay? If you need to restore behavior once the test is complete, for example, you can turn optimizer adaptive statistics back to false, of course. If you need to, you can also remove column group statistics you might have created as well, of course. Okay, now we move on to some more general recommendations. I think you should be aware of these, of course, that you're going to gather statistics for your application schemas, of course. Remember fixed object statistics, remember dictionary stats, remember that you should always gather those. And regarding the adaptive set, and now regarding system statistics, this is some best practice that has changed recently. So if you gather system statistics, then that's fine, okay? That's how your system is running, and I'm not recommending that you suddenly change the way you manage your databases. But our current recommendation is that you use the default system statistics. So in other words, you don't gather them. So the reason for that is fairly a long explanation. So my advice is, if you want to read some more of the background of this, then go to the Optimizer blog, where I talk about the details of the recommendation. The key things are that system statistics recommended you don't gather them, but it's not something you should just do on, for example, a production database, of course. It's something, if you're going to change how you gather system statistics, how you set them, how you use them, you should always test the difference it's going to make, of course. So it's not something you're going to kind of just proactively jump on. But if you're considering upgrading, for example, that's a good decision point for you to decide whether you want to continue to gather system stats. So if you're, for example, doing system testing and you want to kind of move forward with a kind of clean slate, so to speak, then consider deleting system statistics. So that's a change to the current recommended best practice. And if you check out the Optimizer blog, I'll go into that in much more detail about why it's best to take the defaults in most cases. Oracle Database 12c. Other new features are incremental stats maintenance. Now, this is an important thing that changed. You may be aware of incremental maintenance of partition tables. So the idea is you have a partition table with partitions, say, P1, P2, and you have data in each of these. We need to maintain some global level statistics. So in other words, we need to know how the total number of rows that there are in the table, the min and max of all the rows in the table, the number of distinct values in the table. And in particular, in fact, number of distinct values is a difficult figure to maintain. You can't just naively, in some way, aggregate the number of distinct values from each individual partition. You need to have knowledge about the actual data to get accurate values for a number of distinct values of columns. So it's not an easy statistic to maintain at the global level of a table. Remember, this thing could be billions and billions of rows with thousands of partitions. You know, it's quite a big task. How do you maintain the global level statistics? So that's really the point of incremental statistics maintenance, in that the idea behind it is that we associate synopses data with each individual partition, and then we have an aggregation mechanism that maintains the global stats for you. So in other words, what this means is if you add a new partition, let's say P3, and have synopses data, we don't need to keep scanning these these other partitions to figure out what the new values are for global stats. We basically look at the synopses data and figure that out at that point. So it's a way of maintaining the statistics at the table level, at the global level, without having to continuously scan all the data in the entire table. So it gives you an incremental approach to maintaining global statistics. So it was introduced in 11.1. So it expedites statistics gathering. It speeds up how quickly you can gather statistics on partitions tables. Typically, you will set table prefs incremental to true, and you can set things like when to consider a partition stale and how to consider them stale. So that was in 11.1. You may be familiar with it, you may have used it, you may have tried it. So so just to really reiterate, each partition has a synopsis. We maintain information on a number of distinct values, and we then can derive a global number of distinct values from each of the synopses. They're stored in the sysorcs table space, but there is a caveat with that. If you have a very large number of partitions, lots of columns in the table, all the number of distinct values for all the columns in the partition is very high, you can end up with a lot of data stored in synopses. So one of the things you might have seen, if you've ever tried Incremental, or if you're using Incremental, you'll see that quite a lot of space can be consumed in sysorcs. So, and also, of course, it's not necessarily the space that's an issue, but if you have a lot of partition maintenance operation, we of course have to manage that data as well. So that can add an overhead to things like, if you have a large number of partition maintenance operations, you can generate quite a large overhead in maintaining synopses. So that's something we wanted to address in 12c release 2, to make the management of these synopses faster and, in fact, the space they occupy lower. So we have a new algorithm in 12.2 called, and that's set using a preference called the Approximate NDV algorithm. It doesn't really matter what the details of the algorithm are, but if you're interested, you can always look it up, hyperlog. So the idea behind it, it's a small hash table. So in other words, what that means is the synopses associated with each partition are much smaller. So let's say you've upgraded from 12c release 1 to 12c release 2. You'll have the synopses, if you like, in the old format, the pre-12.2 format. If you gather statistics and your preference is set to hyperlog, you can immediately replace those synopses with a new, more compact format. So in fact, this is something to consider. If you're using incremental statistics in 12c release 1 and you're upgrading to 12c release 2, then you want to consider when is the best time to recreate your synopses. In fact, you're not forced to do that. You can, in fact, use repeat or hyperlog, the hyperlog log, which is the preference. This is the default. When you gather statistics, the new partitions will get the compact form, and the old will keep the old. So what I suggest with respect to this is to go and check the Optimizer blog. There's a post on all the various options you have available to you when you want to migrate from the old to the new format. It's something you do want to know about, you need to be aware that it happens, and you may want to choose a point in which you control when it's done. It happens, as I say, over time if you want as well, so you can choose. It's quite flexible, but you do need to know it's there. Okay, regarding SQL plan management, we added new features where you can load plans from AWR. So if you use SQL plan management, you can capture SQL execution plans as SQL plan baselines from the AWR. You can also apply a filter. So in 12.1, if you used auto capture, it would capture everything happening in the system pretty much. But with 12.2, you can specify filters. So in other words, if you use auto capture and SQL plan management, you can now target capture at specific schemas, for example, or specific modules, even specific SQL text. Okay, so it's a neat way of moderating what you capture if you're using auto capture with SQL plan management. Okay, this is essentially how you do it. So you can use the configure option to configure how you capture things. Okay, approximate query processing was added in 12.2. So this gives you the ability to answer certain queries using approximate queries rather than exact queries. So the idea is we added, in fact, approximate count distinct in 12.1, and then there was some new functions available in 12.2, materialized view support. I guess the key takeaway here is that this is very nice for things like dashboard systems with drill throughs, where you've got charts that are being presented to users, and they may have click-throughs where response time is key, but you know the exact height of a particular bar doesn't have to be exact, or the figures don't have to be exact. It's a very nice way to speed up the responsiveness of certain queries that aggregate data. And in fact, what's nice is you can set the behavior using parameters. So in other words, what you can do is to get the approximate results without changing code. It's a very nice mechanism. So for certain queries that have, for example, counts or certain aggregates, you'll get fast performance, approximate answers without having to change code. It's quite a nice little feature. Just to clarify how it works, sometimes people think that approximate samples data in table. It doesn't work like that. Essentially what it does is the exact query scans the data. If you want, say, the number of distinct values, you have to remember the distinct values you see. So this list can become very long, and what happens is you can end up spinning to memory, spinning to temp. So in other words, a lot of those types of aggregate queries expend a lot of memory or sort space on temp and take a long time. The idea with the approximate algorithm is we use a hash table instead. It has a small memory footprint. We don't spill to temp. So the queries then become correspondingly much faster. So less memory, no sorting. So that's what the approximate does. It still scans the table. It's not based on a kind of row sample or anything like that. So the effect of it is that you'll see with the exact query, you'll tend to see sort to temp, say, but when you use the approximate query, you can see sort group by approx. We lose the temp. We're not having to spill to temp anymore. So there's no temp usage. The time's correspondingly faster. So it can make huge differences to response times for those kind of, as I say, really great for dashboards and things like that. Optimizer Statistics Advisor was added in 12.2. So we know that if your statistics are not right in the database, they're stale, missing, they're not gathered in the proper way, then of course you're going to end up with queries that don't perform very well. And it can be quite difficult, of course, to diagnose where your statistics are not right. So that's really the idea of the statistics advisor, is that it applies a set of rules that checks, for example, how you maintain statistics in the database, what the statistics are, and then from that it will generate findings and recommendations. And it will even generate a SQL script for you to implement those changes automatically using actions. So basically it looks like this. So we have rules, findings, recommendations, actions. So it's a series of steps through a workflow, so to speak, in order for you to evaluate whether you have issues with your optimizer statistics or not. So for example, the recommendation, the rule, if you like, is to use default parameters for gather stats. You should always use default parameters when you're gathering statistics. It establishes that in fact you're using estimate percent is 0.01. You've got those in your scripts. So that means the recommendation is that you should use the default auto sample size, and it will generate a script for you to implement that change. So that's essentially the kind of flow, how it works. So the advisor gathers the information. It's a low performance overhead. It does not regather statistics or kind of gather stats in a new way. It queries the data dictionary, looks at what statistics you have. It looks at how you gather statistics. It doesn't kind of resample data, for example. You can choose what you want to look at. So it's very, very configurable. I think my recommendation is you don't need to configure it. Just let it run in default mode. Just let it look at everything, because the overhead is not high. So just let it gather what it needs to gather, and then it stores that information for you to look at later in the data dictionary. You essentially generate reports. So you can generate a report anytime you like. So it's very easy for you to just leave it alone, really. It's automated. If you want to know about your statistics, generate the report. It's that simple. So you can, if you want, create your own task, configure it, and then report on it. But I would just let it execute periodically. That's how it works. I just use it in default mode. So if you want, you can create a task, execute it, get a report. If you just want the default report, you just use this as the name, and it will report the one that runs periodically. That's how I would use it. So just to quickly cover off on the back of that, there are some new DBMS stats preferences. We've already covered these ones: approximate NDV algorithm related to the synopses, auto stat extensions. As I mentioned, this was added in 12C release 2, but it's also available as an interim patch for 12.102. But my advice here is to take the bundle patch. So as I mentioned, take the latest bundle patch for 12.1, apply that, activate it, and you'll get this with it. This comes along with it. Finally, there's preferences override parameter. This is really quite an important one. The idea behind this is that you can actually overwrite defaults. Now imagine you have scripts that currently gather statistics. I mean, you know, historically you may over time have put together a bunch of gather table scripts, and a very common one in scripts is to see things like estimate percent is 10%, for example. That's not best practice. What happens if you want to override that? Do you go diving into scripts and try to fix them? You now have another option, and if you set preference overrides parameter, it now enables you to set a preference such as estimate percent at the global level, and for that to override what you have in your scripts. So it's a very easy way to start imposing best practice upon legacy scripts. So something really worth being aware of. It's a kind of neat way to sort of fix those kinds of issues. Okay, another quick feature, 12.2, expression tracking. I won't go into this into a great deal of detail. The idea is now we actually track the usage of expressions in SQL statements. So for example, if you have select column A plus column B, or column 1 plus column 2 in your queries, we track that usage because, of course, the evaluation of expressions can be expensive. So it's something that we now track. In fact, you can see this happening. So take a look at it. You'll see this data stored in, for example, user expression statistics. We actually associate a cost with this, and we also count the number of evaluations of that particular expression. Why do we do this? It's a useful thing to provide for example in memory, because you may be familiar that in memory we can actually materialize expressions in memory to avoid the overhead of computing them over time. So this is, if you like, in memory is a client of this information. So currently that's the only client, but it's something, of course, that we could in theory reuse down the line. So it's something that we added. Data's flushed every 15 minutes. The evaluation counts are all estimates. We also you'll notice a column called dynamic cost. That's not currently implemented, so just bear that in mind. So in other words, you'll be looking at fixed costs. This is of course a heuristic number. It's something that Oracle has figured out as an estimate and puts in as a cost. It's not an absolute value. Okay. We also added some new columns on user tab statistics for relating to in-memory. So if you need to know more about the in-memory, we've added some new columns on the tab statistics so you can see some more specific numbers. So let's take a look at Oracle Database 18c, Approximate Queries. So we added some new functions for approximate query processing. So these are top-end style queries. So, for example, you can get approximate counts, so approximate sums if you're using kind of ranked queries where you're looking at the top 10 customers, for example. Again, this is kind of handy for dashboards, because quite often, of course, you want a guide to your top 10 spends or what have you, but only an approximate figure. So it's very useful for that kind of scenario. So that's why we've added those. SQL plan management. This is quite an important change again with 18c. You may be aware for standard edition that really the only option you had prior to 18c was to use stored outlines to stabilize SQL execution plans. You're probably aware also these were deprecated in Oracle Database 11G Release 1. So The truth is, however, a lot of people still use stored outlines in standard edition to control their SQL execution plans. They're still available in 18C, but what we've decided to do is to give you a better plan stability option in standard edition. So prior to Oracle Database 18C, SQL plan management was an enterprise only feature. However, in 18 standard edition, we include a subset of SQL plan management features. So the idea behind that is to give you SQL plan management features that are similar to stored outlines. So it gives you the ability to use SQL plan management in a more limited way, but enabling you to control SQL execution plans in standard edition. You can also migrate from stored outlines to SQL plan baselines as well. So it gives you the option of migrating from any stored outlines you have in standard edition to SQL plan baselines in standard edition as well. Basically, the kind of mechanism is you have a query and it's not using the plan you want. You can use a hinted test query to get the plan you want, and then you associate that plan with this query. So it's a way of controlling the SQL execution plan of this query from the outside. So in other words, you can change SQL execution plans using SQL plan baselines and without changing the application. It's quite an important change, really. So bear that in mind, that if you're using stored outlines in standard edition, then you need to look at using SQL plan baselines, SQL plan management in standard edition now. This is a summary of the different features that are available. So as I say, so for example, you can't capture from AWR. Also, plan evolution is not available in standard edition. That's an enterprise only thing. So essentially, it's a way of controlling SQL execution plans in a way that's similar to stored outlines. So that's the idea behind it. That's the motivation, if you like. So let's look at ADWC now, the Autonomous Data Warehouse Cloud. So we had a lot of focus on that, as you might be aware. So that came out recently. So this is for data warehousing applications on the cloud. So we applied some changes in the optimizer area to make using ADWC easier. So pre-18C, you might have been aware of online stats gathering. So the idea here is that when you load a table that's empty with insert append, you'll create statistics. If you do create table of select, statistics are created during the load. Histograms are not created, and we also create any synopses if you're using incremental statistics incremental statistics as well. So that's what you had pre-18. But the key limitation really with this is that if you used insert append and the table is not empty, you would not get statistics incrementally maintained. You'd essentially keep, you wouldn't be updating statistics each time you appended new data. So the idea with extended online statistics gathering is that we do gather statistics now on load repeatedly on non-empty tables. So if you have as well existing histograms on that data, they are also maintained. So if you have a histogram on a table and you insert append, it will maintain that histogram and maintain the statistics. Again, synopses are maintained. So this is a simple mechanism. You might imagine, of course, in a cloud-based data warehouse environment, we need the ability to maintain statistics more transparently. So that's what that's about. Also, statistics-based query transformation. This is a very fancy feature. So the idea here is that if you have queries such as select, min, max, count, those types of queries, and there's no where clause on the query, you potentially, and if you're not able to use an index, you're going to scan all the rows in the table. So let's say I select max num from sales. I could be in a position now of having to scan the entire table in order to get the answer to that query. So they can be time consuming, of course, but of course, if you think about it, when you're gathering statistics on a table, the database retains information like that we in theory know what the min and max values are. We know how many rows there are in the table, provided, of course, that the statistics are up to date. So if the statistics are up to date, we can use them. So what this means really is that we can transform certain queries, these sort of aggregate queries without where clauses, into a query upon the data dictionary to retrieve the statistics instead. So if you take a look at ADWC and try these types of queries, you'll see this transformation in place, and this is what you look for. So essentially this is tells you that you have the potential to use these statistics-based query transformations. My recommendation regarding this, again, is to go to the Optimizer blog. I talk a little bit more about this and have some specific examples of how it works, okay? These are the kind of things that are supported: tables and views, CTAS, and approximate count distinct is supported, count star min max for number and date, okay? The other things, minor change that we made is that you might have been aware that you could enable and disable Optimizer hints with a hidden parameter in the past. They are now exposed. This was primarily done for ADWC again because we want to make it easy. Well, by default on ADWC, hints are actually ignored because generally speaking, the best plans are without hints. However, if you're in a position where you do need to hint queries and run the hinted queries, you can turn those hints back on. But in order to make that documented and what have you, they are exposed parameters now. So just to summarize what I've talked about, so this is the last slide more or less. Adaptive features in 12C. If you're using 12C release 1, look at the recommended patches. That has come in the latest bundle patch. Look at that. Use the defaults in 12C release 2 and Oracle Database 18C. And remember the changes in default behavior if you're coming from a release prior to 12C. Things like incremental stats, the histogram changes, SQL plan management, global temporary tables, those sorts of changes bear in mind. And yep, take a look at ADWC. That's you can again go to the blog. I have some examples from ADWC, for example. If you're looking to upgrade to 12C, 18C, great source of information is Mike Dietrich's blog. So highly recommend you go and have a look there. And also there are things like white papers. They get published on OTN. So the Oracle Technology Network, if you go follow that URL, that will take you to the current set of white papers that are now all 18C. So if you want to know about 18C specifics, then go here. I believe that's it. So yeah, that's it, in fact. So any questions? Okay. Looks like not. Okay, right. Thanks, Francisco. I think we're going to end the broadcast there. Thanks, everyone, for attending, and have a good one. Cheers.